Hello, this is Mr. Dowse. I'm going to go over the first day of notes for the law of exponents. So I'm just going to title the notes as Laws of Exponents. And these are the notes I did the first day of class on the second semester. So the goal of this lesson, or the next few lessons, so the learning objective, the whole goal is to simplify expressions using laws of exponents. So to simplify them as much as possible. Now there are a couple parts to the exponents that I need to address. I have x raised to the power of n, where n is the exponent, and this n is the base. So an exponent is the number that indicates how many times the base gets multiplied. And I'll do an example to explain what that means. And then the base is the common factor So the common factor that gets multiplied. Squeeze them in there. That gets multiplied. And so for an example here is I have x to the fifth power. So the base is x, the exponent is 5. And so if I wanted to, I could write this down in expanded form. It's the same thing as x times itself 5 times. Or if I were to write down 7 squared, so the base is 7, and the exponent is 2, that's the same thing as 7 times itself twice, but that can simplify down even more to be 49. So that's the idea that's happening here. I'm going to throw in a coefficient. I'm going to throw in another part to this lesson. So we have a is the coefficient, and the coefficient is just going to be a number that's multiplying into the base and the exponent. So we have a coefficient is going to be just any number, and I'll give an example in a moment. Then x is the base, and n is the exponent. And so an example here would be 3 times a to the 4th power. So the coefficient is 3, the base is a, and the exponent is 4. And if I were to write this down in expanded form, that's 3 times a times a times a times a. 3 times a to the 4th power is the same thing as 3 times a times a times a times a. So I'm going to write down exponential form, exponential. We're going to make a column out of here on the left, and then I'm going to write down expanded form. I've said expanded form multiple times already in this notes, and so what does that mean? So I'm going to write down a couple examples here. If I had 3 squared, the expanded form of that would be 3 times 3. So it's just the base times itself twice. So if I were to say 7a to the 5th power, that's an expanded form. That's 7 times a 5 times. So this is expanded form, and this is going to become useful later on in the lesson where things can get a little bit more complex. And then we have another example here. I have 14 times x squared y to the 3rd. In expanded form, that could be, or would be, 14 times x twice, because there's 2 next to the x, times y times y times y. There's 3 y's here because there's 3 y's as the exponent. Remember, the exponent is the number that indicates how many times the base gets multiplied. The base is getting multiplied by itself 3 different times. So I'm going to move on to the bulk of the lesson right here. So the bulk of the lesson, we have 3 rules we're going to learn today. One is the power of 1. So the power of 1. And what this is when a number is raised to a power of 1, it equals itself. So this is the rule of thumb on this problem. And I'm going to write down x to the 1 equals x. So I'm raising the variable x to itself, to the power of 1, and so the answer is going to be just x. So I'll give a couple examples here to give this in more detail. I'm going to say if I were to raise 5 to the power of 1, you get 5. 7 times x to the power of 1 would just get you 7x. We're raising both things here by the power of 1. I'm going to say just the variable a raised to the power of 1 gets you a. So the idea is if you multiply anything by the power of 1, you just get itself back. And that's the idea. So let's write down the power of 0. This is the next little rule. Power of 0. So when a number is raised to a power of 0, it equals 1. And the general rule of thumb that I'm going to write down here is x raised to the power of 0 equals 1. And x can be any variable, x can be any number. Anything raised to the power of 0 is always going to equal 1. So I've got a couple examples here as well. I've got 5 to the power of 0 equals 1. 7x raised to the power of 0 equals 1. And then I also have, I guess that'll be it for now. So the idea is if you have any number or any variable, here I'll just do this, I'll do a to the power of 0 equals 1 as well. So I'm kind of being consistent with the previous examples. And if you're confused by this, you can always plug this into the calculator, and you will always get the answer of 1. So for example, if I were to type in 5 raised to the power of 0, I get 1. And if you're confused on how to raise the power, you hit this little caret button under the clear. So 5, I'm raising it to the power of 0. That gets me 1. Sorry about the reflection. And so that's the idea. If you raise anything to the power of 0, you're going to get 1. And this can be crazy. I mean, I can have a times b squared times c to the third. Let's put a coefficient in front of this of, let's say, 6. If I were to raise all of this by the power of 0, your answer is still going to be 1. That's always the case. There is one exception. It's a minor exception. Is you cannot have x cannot be equal to 0. So in other words, I cannot say 0 raised to the power of 0 equals 1. That is not true. It's undefined. So this is like one little exception. If I take 0 raised to the power of 0, you get an error. It's undefined. So that is not the case. So if you raise anything to the power of 0 except for 0, it'll always be 1. But you will probably never see this, but I feel like I should go over that. So anyways, there's one more rule to go over. It's the negative exponent rule. And this is one that is confusing to a lot of people. Of the 3 that I'm going over today in this video, this is the hardest one, in my opinion. And so I'm going to write down this definition here. It says when a number is raised to a negative exponent, comma, take the reciprocal of the base and switch the sign of the exponent. And I'm going to write down a couple examples here, but let me write down like the general rule of thumb. I have x raised to the negative power of m. That's the same thing as 1 over x to the m power, but this is the simplified version. So if I want to simplify x to the negative m, you take the reciprocal of the base, which is the reciprocal of the base. The base is x, so the reciprocal is going to be 1 over x. And then you just switch the sign from a negative n to a positive m. Or there's another way of looking at this one. If I had 1 over x to the negative m, that's going to equal x to the power of m. So if I take the reciprocal of the base is 1 over x. Reciprocal of 1 over x is just x. And then we switch the sign from a negative m to a positive m. This is like the general rule of thumb when it comes to the negative exponent rule. So I'm going to do a couple examples here as well. I'm going to have one example here is x to the negative 3. So this is a negative exponent, so I need to follow the negative exponent rule, which is we take the reciprocal of the base, which is the base is x, the reciprocal is 1 over x, and we make this negative 3 a positive 3. And that's the answer to this first problem. Or if I look at another example, 4 to the power of negative 2, well, what's the reciprocal of the base, 4? Well, the reciprocal is 1 over 4, but we switch the sign from a negative 2 to a positive 2. But I can simplify this down even more. The goal of this lesson is to simplify exponents and expressions as much as possible. So this is really 1 over 16. This is the correct answer. This is correct, but it's not completely correct. It can be simplified down more, so it's 1 over 16. If I got this on a quiz or a test, I would give partial credit. I wouldn't give full credit. You can simplify it down even more to 1 over 16. Another example here would be, let's say, 5 to the negative 1. The reciprocal of the base is 1 over 5. This is a negative 1. That negative 1 becomes a positive 1. But remember, with the power of 1, anything raised to a power of 1 becomes itself. So this actually simplifies down to 1 over 5. So let's do another example. 10 to the negative 2. Reciprocal of 10 is 1 over 10. We change this from a negative 2 to a positive 2, so that's the same thing as 1 over 100. So again, I can simplify 10 squared to 100. Do a couple more examples here. So we would have, let's say, 3 times x to the negative 4. What does that simplify down to? Well, this is a coefficient. There's no exponent attached to this, so that 3 is going to stay a 3. And then I'm actually going to look at this as 3 times x to the 4th power. So I'm going to separate these as the coefficient and then the x to the negative 4. Well, what's the reciprocal of x? That's 1 over x. We switch this from a negative 4 to a positive 4. But this isn't the right answer completely. I mean, this is mostly correct, but the goal is to simplify this as much as possible. The goal is to have this combined as one number. So I'm going to do a trick here. I'm going to make this 3 a fraction, 3 over 1. And when we multiply fractions, we take the numerator times the numerator, 3 times 1, and the denominator times the denominator, 1 times x to the 4th. Sorry, it's a little messed up. And you get 3 over x to the 4th power. This is 3 to the x negative 4 simplified as much as possible. And I'll do one more example here. Actually, I'll do a couple more. I'm going to start on another page. Actually, I'm going to do a couple more examples in a moment. I've got a couple other cautionary moments, not really rules, but this is a couple things to kind of hints and clues to kind of pay attention to when it comes to these kinds of problems. I want to caution that if you come across a problem like negative x, that is not the same thing as 1 over x. So a lot of people are right now thinking, oh, there's a negative here. This is a negative exponent rule. When in reality, this is just a negative x. There's no exponent here, so there's no negative x. So this is just going to stay negative x. So you can't simplify this. So can't be simplified. But if I gave you x to the negative 1, this now has a negative exponent. This is the same thing as 1 over x. So these are equal. These are not equal. So keep in mind. And then also, there's something important to remember here. Remember, an exponent applies to only the factor it is directly next to, unless, important, unless parentheses enclose other factors. And an example here would be, I'm going to give you two examples, would be if I have negative 3 squared in parentheses and negative 3 squared with no parentheses. So the thought here is this negative 3 is included, like, or combined. This is a negative 3. So this is like a negative 3 times a negative 3, which is equal to 9. But this right here, this negative is not included with the 3 because it's not enclosed with parentheses. This is like a negative 1 times 3 squared, which is a negative 1 times 3 times 3, which is a negative 1 times 9, which is equal to negative 9. So keep in mind here, these look almost identical, yet they give us different answers. And so the parentheses enclose the negative, so this is a negative 3 being squared, whereas there's no parentheses. This is just a 3 being squared, and we're multiplying it by a negative 1. And so I feel like I should probably go over maybe a couple more example problems here, just because I know a lot of my students are a little confused on this. So I'm going to continue doing a little bit extra practice here. So extra practice in the notes. I'm going to do 8 problems. First one is 3 to the 0 power times 3 squared. I'm going to simplify this. Now this is the power of 0. Anything raised to the power of 0 is just 1. So this is just 1 times 3 squared, which is just 1 times 3 times 3. We don't really need that 1. This just becomes 9. If I do a second problem, I'm going to have negative 2 raised to the power of 0. Remember, this is the power of 0 here. Anything raised to the power of 0 is just 1. So the answer here is just 1. The third problem I have is 3 to the negative 4. This is a negative exponent attached to this 3. So the base is 3, the exponent is negative 4. So this is a negative exponent rule. You take the reciprocal of the base, which is 1 over 3. You switch the sign from a negative 4 to a positive 4. And that's the same thing as 1 over 3 to the 4th, or 1 over 3 times 3 times 3 times 3. And this simplifies down to 81. So 1 over 81. Fourth example I'm going to do here is negative 4 in parentheses raised to the negative 3. Now keep in mind here, the parentheses are enclosing this as a negative 4, so this is the same thing as a negative 4 on the inside. And so if I were to take the reciprocal of negative 4, because I have the negative exponent rule here, I would have 1 over negative 4. I'm going to keep the parentheses, and we're going to change the negative 3 to a positive 3, so I'm using the negative exponent rule. It's important to keep the parentheses here, and this is the same thing as 1 over negative 4 times negative 4 times negative 4, or negative 4 times itself 3 different times. And that gets you 1 over negative 64, or just negative 1 over 64. So these are both correct, but this is the best answer. Because this is just this whole number is a negative, so it doesn't really matter where the negative goes. The fifth example I'm going to do, and this is a tricky one, is 2 to the negative 3 over 5 to the 0 power. So I have a negative exponent on top, and I have a 0 exponent here. I like to simplify these as much as I can before I do anything complex. I know anything raised to the power of 0 just becomes 1. So this is really just 2 to the negative 3 over 1, which is just really 2 to the negative 3. And so now this is a lot like number 3 here. I'm going to take the reciprocal of the base, which is 1/2. And I'm going to switch the sign from a negative 3 to a positive 3. And that simplifies down to 1 over 8. Because 2 to the third power just gets you 8. Sixth example I'm going to do here is possibly the hardest one of all of them that I'm doing here, is negative 3 squared over 2 to the negative 3. Now this is, I'm going to show you a shortcut. In all these examples that I've been doing with a negative exponent, if it's a numerator, I'm eventually putting it down to the denominator. Or if it's in the denominator, I'm going to end up putting it in the numerator. So the trick of the trade here is if I just look at the fraction, negative 3 over 2, what is the reciprocal of negative 3 over 2? It is 2 over negative 3. So I'm ignoring the exponents here, and I'm only looking at the bases. And essentially, if it's a numerator, I'm switching it to the denominator. And if it's a denominator, I'm switching it to the numerator. And then all I need to do now is, oops, that's supposed to be, oh, that's a positive 2. Oh, wait. I meant that to be a negative 2, sorry. So sorry about that. I meant this to be a negative 2, not a positive 2. So when I have the negative exponent rule, you end up just swapping the fraction here to make it a 2 over negative 3 in this case. And I'm going to change the negative 2 to a positive 2, and the negative 3 to a positive 3, and then we can simplify from here. 2 to the third power is 8. And then a negative 3 times a negative 3 is a positive 9. So I'm going to have 8 over 9. Seventh example, I have 4 to the negative 1 over 7 to the power of 0. So anything raised to the power of 0 is just 1. This is really 4 to the negative 1 over 1. And if I look here, I have a negative exponent. So I'm going to essentially just move the numerator down to the denominator. And this ends up becoming 1 over 4. So you can look at it like this. This is 4 over 1. What's the reciprocal of 4 over 1? It's 1/4. 1/4. But this negative 1 becomes a positive 1. And this is the power of 1. Anything raised to a power of 1 becomes itself. So that becomes 1 over 4. And the last example I'm going to do here, I know these are long notes, but the point is help out people who are in trouble by giving additional examples. So I have 3 to the negative 1 over negative 5 to the power of 0. Again, anything raised to the power of 0 just becomes 1. So this is 3 to the negative 1 over 1. And if I look at this fraction of 3 over 1, since I have a negative exponent, I'm going to take the reciprocal of 3 over 1, and that gets me 1 over 3. And this negative 1 becomes a positive 1. And anything raised to the power of 1 just becomes itself. And I get 1 over 3. Anyways, I hope this helps out. If you're still confused, please come to tutoring. The tutoring times are on the syllabus in the Google Classroom for your particular class. Anyways, have a good day. Bye-bye.